Hello friends, I am Prabhat Sharma and today we will learn how to install OpenObserve on Amazon EKS. So before you start, you must have an Amazon EKS cluster in place. And if you don't have an EKS cluster already in place, you can use EKS CTL to create an Amazon EKS cluster. And I have provided a sample configuration for the EKS CTL. And if you take a look at this configuration, okay, this is the file that will be used by EKSCTL to create an EKS cluster. It will install version 1.30 of Kubernetes, and the name of the cluster is going to be O2. Okay, it'll have a VPC. It'll also create a VPC with this particular CIDR block 10.1.0.0/16, and it will create one managed node group of type m7i.xlarge with 3 nodes. Okay, minimum size of 3 and desired capacity of 3 with a maximum size of 6. We're also setting OIDC to be true, and we'll discuss later what that means. And we're setting some Amazon EKS add-ons to be available beforehand, like CodeDNS, VPC CNI, kubeproxy, and EBS CSI driver. EBS CSI driver is an important one that we are going to need. And we're also setting up CloudWatch logging. So, and if you run this particular command, it will download. If you have not already cloned this repository, and you don't need to, using this particular command, it will download this particular file on your local laptop, and then you can run this command to create an Amazon EKS cluster. Make sure that you have credentials in place that allow you to create Amazon EKS cluster. Once the cluster is ready, we will require Helm. Helm is a package manager for Kubernetes that will allow you to install OpenObserve on Amazon EKS. Now let's take a look at what are the next steps. But before we take a look at the next steps, let's take a look at OpenObserve architecture. So OpenObserve can be installed in a single node mode or in an HA mode or high availability mode. And in high availability mode, if you look at the architecture, you have these agents that will send data to OpenObserve. In front, here is a load balancer. And behind the load balancer, there is a router. So router is an OpenObserve component which will accept all the requests. And if the request is to write some data, it will forward the request to the ingesters. And you can have one or more ingesters, and ingesters can scale horizontally. And if there are read requests, like query, if you're searching for a particular something, or you're trying to do some analysis, then the router will send requests to query. And because you have so many pods out here, how do each of these pods know that others exist? In fact, how does router know that there are 5 or 3 or 100 ingester nodes? And how many compactor nodes are there? All of this. So for cluster coordination, OpenObserve will install NATs within the cluster. At OpenObserve, we used to support etcd initially, but we have learned through not in a good way that etcd is really a pain to manage. Okay, so we don't really recommend etcd anymore. And the default Helm chart of OpenObserve, it uses NATs for cluster coordination and messaging. Now, OpenObserve also stores data on S3 in an HA mode. That's mandatory. In fact, an object store is mandatory, not really S3. So you can install OpenObserve can use Amazon S3, MinIO, GCS, or Azure Blob, or any other object store with an S3 compatible API. And there are many out over there, including from Dell, NetApp, and many other vendors. Now, we have a lot of files over a period that will get into S3. Now, in order to reliably know how many files are here, instead of making get or list calls to S3, in order to be more efficient, OpenObserve uses Postgres or MySQL, any one of these. We recommend Postgres. Uh, so the list of files, which files are there, what is the location in the location in S3, that is all stored in Postgres. Additional metadata is also stored in Postgres, and this additional metadata is around how many users are there, which all users are there, how many dashboards do you have, okay, how many alerts do you have, okay, and a bunch of other information around that. Okay. And enterprise version of OpenObserve, for single sign-on, OpenObserve works with DEX IDP. It's an open source tool for single sign-on. Also, for role-based access control, OpenObserve uses OpenFGA. So that's brief information about what all the architecture of OpenObserve. And now that our cluster itself is fine, is available, we need to make sure that we have S3 available, and a bucket in S3 available for that OpenObserve can write data to and then read from. Now, we also need to make sure that OpenObserve has access rights to write and read from this Amazon S3 bucket. So how do we do that? So what we have here is a file called bucket.sh. What it does is that it creates an S3 bucket. It also creates an IAM policy and role that OpenObserve pods can use for reading and writing data to this S3 bucket. We'll quickly go through this. In fact, I have this repository cloned on my local machine. So let's take a look at what does this do. So the first thing that this script does is that it sets the cluster name of Amazon EKS as O2. Make sure that you update this particular line and put the cluster name here, whatever is your Amazon EKS cluster name. Then it gets AWS account ID and region and OIDC ID. We'll talk about this later. And then once it has all of this, what it does is that it creates a 5-digit random number and then creates a bucket name of OpenObserve hyphen and that random bucket number. And then it goes forward and creates an S3 bucket. Now that we have the S3 bucket ready, after this line, we want to create IAM policy and role that will allow OpenObserve to access this particular bucket. That is where these lines come. Okay, we create a policy by the name OpenObserve policy, and this is the definition of that policy document. You have put get, list, and delete object, and whatever is the bucket name here. And on this line, we go ahead and create the policy. Once we have the policy ready, we'll go ahead and create a role. So we give a role name here and description. And on this particular line, we create a role. Okay. Once the role is ready, okay, and you'll see that there is a condition here for string like OIDC.EKS. And we'll show you later why this is needed, and also this role essentially is for EKS, EKS OIDC, okay, connect OIDC connector. Now, once the role is created from this line, we'll get the role name, and on this particular line, we'll attach the policy that we created above, this particular policy, to this particular role. Okay, so that happens on this particular line, and that is all we needed. And then we'll output the bucket name and the role ARN that we will use later when installing OpenObserve. So let's take a look. This is my AWS account. Let me refresh the bucket. I have just one bucket here, but then simple one hyphen some long number. Okay. What I'm going to do is, let's go ahead and execute this bucket.sh. Once I do this, what is going to happen? Let's see. It will take a couple of minutes. We'll create a policy, create role. So it created a bucket, and it also created a role. Let's go and check what we have here. So we got a bucket 29608, and let's refresh this. IAM role. We've got an OpenObserve role, and OpenObserve, a policy by the name OpenObserve, starting with OpenObserve. We have an OpenObserve policy. Okay, if you look at this OpenObserve policy, it was created on August 25th, 2024, 8:41, which is what the time is in San Francisco Bay Area, California. Okay, the same as with this particular role. Okay, created on August 25th, 2024, 8:41. Okay, and you should see that here is a permission policy. This is the OpenObserve policy, and this is literally the policy, OpenObserve policy. And you'll see that this particular policy has access to put, get, list, and delete objects on this particular bucket 29608, which was created a little while ago on August 25th, 2024, 8:41, which was a couple of minutes ago. So now let's go and look at our steps. So we ran this. Now everything is ready. Now we will download a values.yaml file. So OpenObserve uses Helm to install OpenObserve in an Amazon EKS cluster, and Helm is the package manager for Kubernetes. So, and the configuration that Helm uses is through a file called values.yaml, and let me show you. So this is the repository for OpenObserve Helm chart, and here is this is the repository for OpenObserve itself, and this is the values.yaml file that I was talking about. So it has a lot of configuration. You can download the file from here, or here is a shortcut. You can just copy this and download the file, paste it, and run this, and you'll get the values.yaml file. Fantastic. Okay. Now you have the values.yaml file. Now we need to update 3 items in this file. The first one is that we need to update the service account. Service account is the means by which pods in a Kubernetes cluster get access rights. And that is exactly what we are going to be using to allow OpenObserve pods to access S3. And remember, we created an IAM role. We'll use that. So let's go to the service account section. This is where it is. And the way you do it for EKS is that you set up an annotation here. So I uncommented this. Let me delete this. And there needs to be a tab here. And I need to go ahead and update this IAM role. Okay. So remember, this was the IAM role that was created. So I'll copy this and I'll paste it here. So that takes care of access. Now update the bucket name. Yes, we need to tell OpenObserve where to write. And what was the bucket name? OpenObserve -29608. Let's copy this. And let's search for bucket. Okay, so 0 is 3 bucket name. Let's paste it here. Make sure that your region is right. My bucket is in US East 2. You make sure whatever region your bucket is in, your cluster is in, you set it here. Okay. Now the bucket name is done. Now update the credentials. These are the credentials for accessing OpenObserve cluster once OpenObserve is installed. So that you should be able to find pretty much near the top. And you'll have a section called auth. Okay. You have a zero root user email and zero root user password. Let me change this to prabhat@example.com. And complex, let's make it super complex. This is going to be my username and this is going to be my password. You can keep it whatever you want. Okay. So now, once this is done, let's move on to the next step, installing OpenObserve itself. Fantastic. But before that, we need to set up some prerequisites. And the first one is Postgres. Remember, we talked about, we created this particular section about S3 and any access that is required for S3. Now, all the files that are going to be in S3, we need to create a list of that. Okay, I mean, that list needs to be maintained somewhere, and we'll be using Postgres. Now you can bring your own Postgres instance. You can create one from RDS, or if you don't do all of that, then to make your life simple, OpenObserve uses something called Cloud Native PG to install Postgres in your cluster. You'll create one instance of that, and that will be used by OpenObserve. So Cloud Native PG is a PostgreSQL operator that makes it easy to install and manage a Postgres instance in Kubernetes cluster. Okay. Generally, I would recommend you to use RDS, but this is pretty fine, and taking backups and restoring is actually quite easy with Cloud Native PG as well. Now, okay, so in order for us to install Postgres in the Kubernetes cluster itself, we need to install this Cloud Native PG operator. So this is the command that you're going to be using to install the Cloud Native PG operator. Okay. So this is the command that we'll be using to install Cloud Native PG operator. I have already installed the Cloud Native PG operator on my cluster, so we are not going to be needing that. Okay, now create a storage class for GP3 volumes. Now here there is something that I want you to know. Now, so how does storage work? Let me come back here into the architecture. So OpenObserve, whenever these log forwarders like Fluent Bed, Fluent or Vector or Rotel Collector, they send data to OpenObserve. It comes via load balancer to a router, and router then sends to ingester. Now, ingester will accept that data and store this information locally on the disk, wherever that pod is running, and will not send immediately to S3. Why not? S3 is not designed for very small writes. While it can do, it is not efficient at doing so. It is also going to be expensive because S3 pricing is based on number of requests that you make as well as storage. So if you have 1 MB file and you are writing 1,000 1 kilobyte files, you're making 1,000 requests. That'll cost you. It's better to just make single request to S3 with 1 MB file, and that is going to be a lot cheaper for you. So what ingester does is that it caches the data locally. It stores essentially, or buffers. Buffering is the right word. So it buffers the data locally for some time, and then periodically it will go ahead and push this data to S3. So in order for ingester to store that data locally, it needs to have a volume, an EBS volume. And the way we OpenObserve Helm chart works is that ingesters, the ingester pods that are created, they are created as part of a stateful set. And with each of these stateful sets, there is a PVC or persistent volume claim associated, okay, or attached. And that data will be stored, anything the data that comes will be stored on that PVC temporarily before it is pushed on to S3. Also, the queries, while they're stateless, they also have data stored locally on them that is used as a cache for the data that is in S3. Whenever a user queries certain amount of data is first fetched from S3 onto the querier because it is a lot faster to query locally from the EBS volume than from S3. It'll cache it locally, and any subsequent requests that are made will be made from the query itself, from the pod. So queries are also set up as stateful volumes, okay, stateful sets. Okay. So, and these volumes are going to be your standard EBS volumes, GP2, GP3, IO2 volumes. So by default, the way for you to select what kind of volume that you want to have in Kubernetes is via something called storage class. And let's check by default what storage class that you get. Get SC or kubectl get storage class. So by default, when you set up an EKS cluster, you'll just get a GP2 storage class, which is for GP2 volumes. GP2 volumes are an older generation volume, EBS volume type. You don't really want to use that. You want to use GP3 or IO2. So let's create, if you don't already have one, create a GP3 storage class. And I have provided manifest file for that. Also note that the GP2 storage class, while it is there, it is not the default one. A default one will have, within bracket, a default written over here. So let's look at this. When we create this GP3 storage class, you'll see that we're setting the storage class to be default to be true. The name is GP3, parameters type is GP3. Okay, and this is the provisioner, AWS EBS provisioner. So let's go ahead and create the storage class. And once it is done, we'll simply query it and make sure that it was created. Okay. So get SC. You'll see that now you have two storage classes, GP2 and GP3. And GP3 is default, which is fantastic. Okay, remember we downloaded the values.yaml file. Let's search for something called storage class. You'll see that on ingester, the storage class here is blank. Whenever it is blank, okay, the default storage class will be applied or used. Remember earlier we had just GP2 and it was not default. And if you would have proceeded with installing OpenObserve without setting up a default storage class or providing here either GP2 or GP3, then OpenObserve installation would have failed because the PVCs or persistent volume claims or the volumes that need to be associated with the pods would not have come up. So make sure that you have an appropriate storage class available. So now let's go back to our steps. Now we have the storage class, a default storage class. Then we got to add OpenObserve Helm repository onto your local machine. Helm repo add OpenObserve. So this will add the repository on your local, a link to the repository on your local machine. And this will essentially fetch the latest Helm chart and store and cache it locally on your machine. I've already done this, so I don't need to do this. Now is the time to go ahead and install OpenObserve. You are all done here. kubectl create ns OpenObserve. This command will create a namespace in your Kubernetes cluster. I already have this namespace created. So let's Control L. Let's clear this. K minus O and OpenObserve get PO. So kubectl minus n OpenObserve get pods. We'll try to get all the pods in the OpenObserve namespace. So no pods, nothing. So let's go ahead and copy this and install OpenObserve. Okay. And it should take a couple of minutes and OpenObserve should be installed. So the Helm chart did its job. Now here is a command that you can use. kubectl minus namespace OpenObserve port forward and the router service. Remember in the architecture we talked about the router service? So we can port forward the service locally and access it. By default, the Helm chart does not create a load balancer for you. Okay, and I'll go ahead and explain that, why that is the case, and how we can change that. So first thing first, let's take a look of what we have. Okay, do we have the pods up and running already? We will know. Okay, so we have the pods up and running already. So we have 3 pods for NATS, which is our cluster coordinator. We also have a NATS box, which is not really useful unless you want to debug your NATS. It is just a utility tool. Then you have an OpenObserve alert manager. You also have a compactor. So the job of the compactor is to compact, essentially join multiple files on S3 whenever they are small and compact them into bigger files so queries can become faster. Okay. Ingester, we learned about it, that it accepts data and stores them in S3. We have a Postgres instance. Okay, this is the Postgres instance. And there should be Postgres 0 as well. There's just Postgres 1. Okay, it doesn't start with 0. Okay, and then you have a PG admin. PG admin is not really necessary for OpenObserve to run. It's just there as a convenience tool. If you want to access and debug what is there in your Postgres cluster, you can use this. Then you have a courier pod. Okay, the courier, ingester, all the OpenObserve components are horizontally scalable. Then you have an OpenObserve router pod. Okay, so we are good here. Now we had this particular command. Okay, So by default, this router and all of these services are accessible only from within the cluster. Any service from externally, from an external service cannot really access router or anything. So right now, let's go ahead and try to access this router, which will allow us to access everything. So let's copy this and run this here. So it will port forward on port 5080. The OpenObserve router runs on port 5080, and we are port forwarding it on 5080 locally. Localhost 5080. So it's still port forwarding has not worked. Let's give it a minute. Fantastic. So now it has refreshed. What was our user ID and password? Our user ID and password was prabhat@example.com. Let's copy this. That's my email. And then this was my password. And let's log in. And we are in just like that. No data ingested, which is okay. Cluster just came up. So yes, that is what it is. Okay. And then you can follow ahead and start using. This is the ingestion menu. Okay, you can follow a lot of stuff here, pretty much copy paste and things will work. But when you're running it in production, actual users do not use localhost 5080 or port forwarding. So how do we use it in production? So let's go here. Now, this particular, let's take a look at the architecture. This particular service needs to be exposed outside of the cluster. So you need essentially a load balancer in front of it. So there are two ways to do this. You can either have the service, in fact, let me first kill this. K-n OpenObserve get SVC. Let's get all the services that are available. Okay, so you have a lot of these services available here, and this is the service that we are interested in. The service is of type cluster IP. If you change the service of type cluster IP to load balancer, it will create a load balancer in front of it that will be accessible from outside the cluster. While it will work, it's not the best approach. The best approach is to use an ingress. And there's a section for ingress. By default, it is not enabled. It is enabled as false. And the class name is by default as Nginx. So there's an Nginx ingress controller that you can use. And you can specify, I'll not really be teaching ingress right now here in this session, as that is out of scope. Maybe I'll create a separate session on just ingress, or you can find a good amount of information on internet around how to set up ingress. Basically, you want to set up an ingress controller in your cluster and then use the class name over there, enable it, and then set up the host name. That will allow you to access your OpenObserve cluster externally. Okay. So that is all, friends, for now. Okay, couple more things. Let me show you. Okay, let me close this now. So this particular section, config, if you see, there are a lot of environment variables here. Some environment variables, let me cover those, like compact. Okay. Compact interval, enable true, compaction is enable true, step seconds. In fact, instead of looking at it from here, let's go to environment variables here. There's a good amount of explanation available here as well. And there's one that specifically that I want you to look at, which is compact So here, zero compact data retention days. So by default, all the logs and metrics that you ingest in OpenObserve or traces, they'll be kept for 3,650 days, which is 10 years. Okay. If it is zero, then it will be forever. You might want to set this to 1 month, 15 days, 90 days, or 1 year, or whatever you want, or whatever is your need. And while there are a lot of them, this is where I'll stop. Have a good day ahead, folks. See ya.